In this video I'm going to show you how simple data analysis can be performed based on a Markdown template and on the crash course R, which is a part of the book Mathematical Modeling and Simulation. The starting point is a CSV file with the data, which can be obtained from Excel data by choosing the CSV export function. I will not show the Excel export, and in this video we start with the CSV data, this data here, and we put everything we need in working directory. So I'm creating a working directory here, and now I have put these CSV data into this directory. Now in this working directory we also need some data from the book software. So I'm going back to this directory here, and the MMS directory here is the book software directory, which is delivered with a book, with the aforementioned book. So I enter this directory with the book software, and the first thing I take here is the crash course R file, and I copy it into the working directory. And the second thing we need here is from the templates directory in the Markdown subdirectory, the simple template, and this is this template here. So I copy this template also into the working directory, and now we are ready to start the analysis. Now in the next step I'm opening the simple IMD template in R Studio, and of course you have to install R and R Studio before you can do this. So now I have opened this template in R Studio, and in the next step we can compile this template to obtain a HTML document. This I'm doing now, and this is now the result. So if I'm opening this in my internet browser, which is Firefox on this machine, then I get a Firefox document where we can, which will finally obtain our analysis. It may happen that you get an error message when you are in our studio and try to translate the document using this button here. And these error messages may say that you have to install some packages. If this is the case on your machine, then you just go to the packages part of RStudio and install the packages which are needed. If you don't have R and RStudio on your machine, you can look into the crash course R, which is this file here, and then it takes some time to open. I can enlarge the font a little bit. Then you can go in the contents section to the knowledge database, and there, if you go to installation of R, for example, here you have links to video demonstrations which show how you can install R on Windows or Mac. And the same thing we have for RStudio. There I also have some YouTube links which demonstrate how you can install RStudio for those of you which may not have R and RStudio on their machine. Now I'm back in RStudio, and what I want to show you now is how you can edit this document such that it obtains first analysis of the data file, which I showed to you, of the CSV data file. So I'm going to show you now how you get this kind of document with an interactive table of contents and interactive plots, and which is the first analysis of the data. So the first thing is that you edit the title of the document. So in our case, we want to analyze the CARS 93 data. So I'm writing here example analysis of the CARS 93 data. This is a standard data set which is delivered with R, and I'm using a CSV version of this data set because this gives me the opportunity to show you the workflow, how you get the CSV data into this document. In our case, we don't need a subtitle, so I'm going into this line with subtitle, and since we don't need this line 3, we are writing a hashtag here, which is the comment character in R. So by writing this character here, line 3 is defined as a command line, which is not analyzed during the translation of this document. So we won't have a subtitle, and we don't need a subtitle in our case. The rest of the title section can remain as it is here. And now I'm going, this is an important button if you are working with Markdown because it shows you the structure of the document. I'm now going to the first section here, and I'm editing this first section. In this first section we want to read the data, or maybe we just call it data, this first section, and then I'm removing the other sections here. And in the first section, the first thing we do is we read the CARS 93 data. Now to read this data, we want to perform an R command, which reads this data into the software. And since we want now to write an R command, we need a so-called R chunk. And this R chunk we can get by this procedure. So I'm clicking on this button and then on R, and then you see that here a shaded area appears with this code as starting code and this code as ending code. So here this R chunk begins and here this R chunk ends, and between this line and this line we can write R commands. And we want now to write a command which reads our data into our software and saves the data in the variable D. So I have now to write the file name in, and I can do it in this way. And now by pressing the tab on the keyboard, I can choose between the files that are available in the working directory, and I'm choosing our CARS 93 data, which you've seen before in our directory. And this command now reads this data into the software, And in another R chunk I can now show the first lines of this data so that you can see if the data have been read in correctly. The head command gives the first lines of the data that have been read into the software. So after doing this little programming here, I will translate the result again into an HTML document. And this is done now. And again, I'm looking at the result in my internet browser, which is here. You don't see the result right now because you have first to refresh your view, which I can do using this button here. And now you see that the document has changed. Here you see the new title, which I've just written into the in RStudio into the RMD document, and you also see the first section called data, and you see the texters which I've written here. Read the cars 93 data, and this command has read the data into the variable d, and by performing the head command you can see the first few lines of the data set. So the data set has several columns: manufacturer, model, type, min price, price, max price, all data related to cars. And then you see the first six entries in the columns. For example, in the manufacturer column, these are the first manufacturers, these are the first prices, and so on. Okay, now we edit this document a bit. For example, this note here, I think we don't need in this document, so I can remove it. I go into RStudio and I'm going to the top, and there we should have this note here. Here's the note, and I just remove it because we don't need it. In the first data section we can now generate some subdirectories by using two hashtags. This is now a second order title. Maybe we just write input of the data. So here we show how we get the data into R. And now what you have seen the first lines generated by the head command, but this is a kind of such not a nice presentation, and I would recommend to use the Crash Course R from the book as much as possible to get interactive tables which look better. So now we generate an interactive table of the data, and this can be done by using a template from the Crash Course R. So I'm going back now to the Crash Course R. We are here. This is our working directory, and this is the Crash Course R. I'm opening it now, and there's a template which can be used for an interactive table. Here under data, example data sets. So in this section, example data sets, knowledge database data, example data set, CO2 data, there's a nice template which can be used to generate interactive table of content. So just take this template, copy it, and go back to RStudio. And again, we want to write an R command, so I'm inserting a R chunk, And here now I'm pasting the template which I have from the crash course R. This template shows a data set denoted by D. So if your data set has, for example, you have called your data set D1 or D2 or whatever, then you have to edit the code at this position. But I don't have to edit anything because my data set is D as it is required here. So, and now if I'm compiling this text again and generating the HTML again, then I get the following result. Now you see that the first line is removed here, that we have a second order title here. And I can use this contents button here to now go to our interactive table, which has been generated here, which gives you a much better formatted overview of the data. So you see I can scroll through the data, and there's a scroll button here, so that I can scroll through the data. I can also sort the data in an Excel-like fashion. I just click on the price here, and then I have the data sorted by price. So this is a much better presentation of the data compared to our first attempt here using the head command. And I would recommend for our analysis that you always try to present your data and your results in an interactive fashion. If you look at this here and you want to present these results, then you probably don't want to have this R code in your document here. And this R code, which you see here, can be hidden in the document as follows. So I go back to RStudio, and then you can go into the R chunk, which produces the interactive table of the data. And then you can write options. So I'm writing a comma here, and then there are several options I can use, and one of these is echo. And echo means if I would set echo to true, then the program is shown in the final document, but in this case I set echo to false, and then this code will be hidden and you get a nicely formatted final result. So I'm compiling the document again, and I'm going back to my internet browser, and again you still see the code because I didn't refresh the view, so you need to refresh the view, reload the page, and now you see I have the interactive table of the data here with no code. It's also important for every data analysis that you explain the variables of your analysis. And in our case we have for example these column names here, and you should explain all these column names in the document. So you need some section like explanation of the variables, and if you're doing it simple, you can just use bullets to explain the variables, model type, min price, price max. I will just write this for a few of the variable names. Max price, maybe I take the max price here, and then for the rest we are writing just some dots here. So what you have to write is manufacturer with an explanation, then an explanation should follow what this column contains. So in this case, it would be the manufacturer of the car. And for all the other columns, you also need to write explanations. So okay. Now I'm saving this, and if I generate the HTML document again, then I'm here, and I can use the contents button to go to our explanation of the variables, and then you have it in this format. You could also, if you have very many variables, you can also generate a table in this style. But at least this kind of explanation should be a part of data analysis. So, and now we go to the analysis part. After reading the data, showing the data, explaining the data, you would do some kind of analysis. So I'm making a second main section, analysis. And in this section you can do, for example, compute some mean values, etc. to analyze your data. So, for example, you can compute the mean value of the prices. And you can write text for this mean value of the prices. And then you can knit it again, generate the HTML again. Now I'm back here, I'm updating the document. And now you can see in the content section that we have the new structure with the new analysis section. And here we have the mean values with the corresponding result. And typically one would then also look at some graphs. For example, we can make a plot of the prices. And to do this, I introduce a new column with line numbers, because I would like to use this in the plot by writing the R command. D $number is all numbers between 1 and the number of rows in D. And with this new column I can generate plots, simple R plots, for example by just writing plot and then D $number, which is the line number, and then D $prices, for example. Let us look at the result. So I'm updating this here, and then I've generated this simple plot here where you see the prices in this data set, and this is just the line number of the data set, and you don't see any kind of tendency here because the prices are just organized in the original order of this data set. So this would be simple plot of the prices, and I would always recommend to use the interactive plots that are explained in the crash course R in the book. So an interactive plot would look, you can generate as follows: interactive plot, plot of the prices. I can show you one option how you can do this using the crash course R. So I'm going into the crash course R. So here is the contents section, and what we need here is in the knowledge database under plots, and then interactive plots using Plotly. And here's template which you can use to make a simple line plot using in a little better format than the simple plot we just generated using the ggplot2 package. And again, I'm just copying the code from the crash course R. Copy, and then I go back to this place here, and I insert an R chunk again, and in this R chunk I paste the code, and I have to edit the code a little bit so that data set is D, and on the x-axis we want to have the line number, and on the y-axis we want to have the prices. So I'm writing price here, and now let us knit this and look at the result. So this is our document here, our analysis document. So this is the contents. We are in the analysis, and now interactive plot of the prices. The first thing we did now is just a simple plot using the ggplot2 package, where the result looks a bit is a bit better formatted than with this simple plot command here. So maybe we should write here, first step would be plot using the ggplot2 package. This is the first step towards an interactive plot, and now the second step is using the package which makes the plot interactive, the Plotly package, to make the plot interactive. Yeah, and so I go back to the crash course R, knowledge database, plots, interactive plot using Plotly. And now you can see what we have to do. We just have to load the package that makes the plot interactive, and generate the plot using the ggplotly command. And this is exactly what I'm using now. So I'm inserting an R code again, and with this command we can now generate an interactive plot. This should work if I'm compiling this. So now I'm back in my analysis document. Yeah, as you can see, now we have generated a plot which at the first glance looks like the previous plot, but it's interactive now. So if you move the mouse into this plot, you can, for example, select particular regions. You can see the data. If you move the mouse, you can go back by a double click. This is now an interactive plot. If you look at this plot, you see that here are some messages which you don't want to see in your final document. And to switch off these messages, you can again use chunk options. So I would now use the option message is false. I set message to false, and also I can use the echo option again to hide the code. We can do this here too. Echo, set echo to false, so that we just see the plots in our final results and we don't see the coding. Now I am compiling this again, translating it again to HTML. Here I'm back in my document, and now you see this is our section. First step, ggplot2 package. Now we just see the graph with no coding, and then the second step, I will change this to second step, which gives an interactive plot. So I go back to this place here, second step. Okay, so this is a simple interactive plot. Simple interactive plot, and I will now add a more sophisticated plot. Plot using of several columns, using a for loop, just to show you what you can do using the crash course R. So if we go into the crash course R, here we have the programming section, and there's a section performing repeated operations, and there we have creating interactive plots in for loops. And there's a nice template here which we can use, which is this one. Sorry, I made a little mistake. I'm starting again in this section of the crash course R, creating interactive plots in loops. And now I'm going to a template that works well for our case. And this is this template here, a plot with automatic construction of a legend. So I take this entire code as before, copy, and then I go into our coding in our studio. I insert an R chunk again, and inside this R chunk I paste the code which we just took from the crash course R. And in this code we want to have the line number on the x-axis as before, and I think we will generate a plot of the 3 price columns of the data set. And these, let us just look what the names of these price columns were. So I'm going back to our analysis document, into the data section, and I want to have these 3 columns here, and I take them by copy and paste into my coding. So I want to have these 3 columns. I paste them here, and of course we have to use dashes, double dashes around the text to make sure that it works well. Okay, so that's correct now, and in the next line we can define the labels for the legend. So we can write here minimum. I think we can just take the same names here for the legends, but you could modify these names if you like. Okay, this code should work. I will set again the echo to false, because we don't want to see the coding of this plot. And then I knit the document. And we look at the result here. So I go to the analysis section, plot of several columns. So this is the result, but this is not an interactive plot right now, because I've just used the ggplot2 package here with the ggplot command, and we can do the same thing which we did here for the simple interactive plot. So we just have to use this command here to make the plot interactive, and this is exactly what I'm doing now. So I'm replacing this command here by this one, and this then generates an interactive plot. Let us look at this interactive plot. So I'll refresh the view, and now this should be an interactive plot. Yeah, I think I'll make it a bit smaller here. And now you can see that this is a very nice interactive plot where you can select individual lines like this. If you want to compare this with this one, you can add all line plots that you want to see here. And as before, you can enlarge the view as desired. So this is a very nice interactive plot, and it shows again how these sophisticated plots can be generated by a simple copy and paste from the crash course R. I will now add one more example of nice plot, nice 3D plot from taken from the crash course R. So this is now a 3D scatter plot example. Suppose we are interested in the interaction between length, weight and price of a car. Then we can do simple things. We can, for example, compute the correlation. So what we can do, for example, we can compute the correlation between the length data and the price. And in this case, you see we have a positive correlation as expected. This means that the price increases when the cars get larger, when the car size increases. Okay. We can also generate two-dimensional plots, two-dimensional scatter plots. I can take the interactive plot from above as a template, so we can use exactly this programming here again. And again, this shows you that the analysis can be built up just by copying and pasting programming templates. So now I introduce an R chunk again, and then I paste the code which we used for the interactive scatter plot. I have to replace this by ggplotly p in order to generate an interactive plot. And here we want to see on the x-axis the length and on the y-axis the price. This should work. Let us look at the result. Okay, so I'm refreshing the view. So, and we are here now, 3D scatter plot example, and here you see the interactive plot which we just generated, and you see a rough linear tendency here. So you see that the price increases, that the trend is that we have increasing, almost linear increasing prices with the length. And again, it's an interactive plot, and you can look at all details you're interested in. But of course, we have three quantities, and we want to understand interaction between three quantities. And there we can use a 3D scatter plot. And this is what we use, what we are taking now from the crash course. Yeah. So now a 3D scatter plot from the crash course R. So I go to the crash course R. In the knowledge database, plots, 3D scatter plots. And before we can use a 3D scatter plot, we need to write these two lines of code here. So I'm taking this into our programming. I'm inserting an R chunk and paste these two lines of code here, which load the package and load packages and the RGL package which generates the 3D plot and which issues this command here, which is required to make the result interactive. So this is a preparation, but we don't want to see this in our final document, so our write echo is false as before. And now we can, by the way, the CAS 93 dataset which we are using here, you remember that we read it from a CSV file. If I go back to the data section, you see we use this command to get the CAS 93 data. And I told you that I did this because I wanted to show you how you can get CSV data into R. But I also said that the CAS 93 data set is delivered with every R installation, and it can be accessed by this command. So this command loads the mass package of R and takes from this package the CAS 93 dataset. So we could have also used this command alternative to this programming to get these data. Okay, now we take the 3D scatter plot programming template. This is this one here. Okay, again, just with copy and paste into our program. So I'm opening another R chunk and insert the coding here. And in this case, I don't need to change anything because The example in the crash course was also done for the same data which we are analyzing here. You can see here what you have to do if you want to see data different from length, weight and price. You just have to change the column names here, and then you get a different result in your graph. Okay, so let's put this into our document. We just get a little error message because a package was missing, and I just installed it. As I told you before, if a package is missing, you just go to the packages part of RStudio and then to install. And in my case, I was missing the color ramps package, this one here, and I just installed it. And then I pressed this button again, and then it worked, and this is the result. So let's look at the result. 3D scatterplot example. Oh yeah, what we also should change here is that in this scatterplot programming, of course, we don't want to see the programming in the final document, so I'm writing echo is false as before. So I need it again. In this case, there appears a small window which you can neglect, which is produced by the RGL package. The nice thing is that the 3D graph is a part of the HTML document, as I will show you now. So now we go to the 3D. Okay, there's a problem. Okay, as you see, we have a package problem again. There's no package called fields. And in this case, I think I show you how I'm installing it. So I'm going back to the package, packages section, install, and we need the package called fields. Here it is, and then I press the install button. Of course, you need an internet connection for this. And after this, it should work. So this is now the message after the installation. Done fields, then it should be correctly installed. And I go back into our programming. By the way, you may have noticed that I switch directly between all these sub-windows here. What I'm doing is that I'm changing between all these sub-windows, these so-called panes, and I'm using these keyboard shortcuts. So if I want to go back to the programming, I'm using Ctrl-Shift-1, and then I'm back in the coding here, and I can then restart the compilation, and I hope that this will now generate the final result. Okay, there was again an error message because I didn't read our own crash course R. This is an important information that we have to use a chunk option if we want to see interactive 3D RGL plots. So I need this chunk option in the programming of the graph. So I use a comma, and then I insert this chunk option, and then it should work, hopefully. It's not bad that we get error messages here, because it shows you how the real work with R and RStudio is, and it's just a normal thing here that you have to go through several iterations until you get the result as you want to have it. I think I remove this price bar here because this is not so well formatted here. So I can go into the programming here, and I don't want to see the color bar here, so I just I'm removing it. I have marked all this code which I don't want to have with the color bar, and then I can what I could do is I could write hashtags in the first position in every line, but this is a lot of work, so it's better to go to this place and comment lines, which I usually do again by a keyboard shortcut. But you see now all these lines of code are inactive because they have the comment sign there, and now I redo the compilation, and let's look at the result. So now the result looks better, and this graph can now be controlled by Morse operations, so you can turn it around to understand your data. And it's much easier to understand three-dimensional data using a three-dimensional plot like this, because you see all dependencies at the same time, and you can use coloring of the data points to add further information into your plot. Okay. Now, last thing I want to show is how you can write references to sections, figures, and literature to make the appearance of the document a bit more scientific. So first of all, if you want to create a reference to a section, you can do it like this. This is an example reference to section, and then you write this code. Ref, and assume we want to do a section to the reference to the data section. So I'm writing here label. Let's just write data. Data label. It's better to write something different from this name, data label. And now this data label must be assigned to this section here, and this can be done by adding this code to the line which defines this section name. So I just write hashtag with the label that I'm using enclosed in curly brackets. Okay, and then it will work. So this is the way you write reference, and this label you have to write at the section you want to reference in this way, and this will work. So let's generate the HTML document again. This is ready now. And now we have this example reference to the section, and this is interactive, so I can go into this position, and then it brings me directly to this section. Okay, next thing, references to figures. Let's take this simple interactive plot here and assume we want to generate a reference to this plot. Then this is the interactive plot here. Then I have to add a figure caption using the option fig cap here. And then enclosed in dashes I can write the caption. The caption would be here, for example, this is a nice interactive plot. And then we need again a label to connect our coding with this plot. So let's take this as label, int plot for interactive plot. And this is the label which I'm using now in an example reference to the figure. And here I use this int lab. But in the case of the figure, you have to add fig and then a double dash to make this reference work. So let's see if it works. Okay, it's ready now. And now, after refreshing the view, we now have. Okay, the referencing didn't work. You may have noticed that I used the wrong label. The label is int plot, and this is what I have to use here, and then it should work. So let us knit it again. Okay, now it would hopefully work. Okay, it works with no problems. This is an example reference to figure 2.1, and figure 2.1 is now the interactive plot which we have referenced in our coding. So you see it works, and in this way you get a scientific way, you can realize the scientific way of writing in this Markdown document. Okay, now I want to show you how you can do references to literature. We are using, I've added in our working directory here, I've added this file here, which contains literature database in BibTeX format. I've just opened it in an editor. It should open up. No, it should open. Yes. So these are literature references in BibTeX format, and let us assume we want to reference this book here. Then I need this code here from the database, and if you want to work with BibTeX databases, there's software which you can use. For example, in the GM Linux system, which we have here, there's a software called Yapref, which allows you to work with a literature database in a graphical user interface, in a comfortable graphical user interface. But for this demonstration, it's sufficient to work in this way. So I want to now generate a reference to this paper, to this book, and the syntax is like this. So this is an example reference to a book, and it can be done in this way. If you want to do this, of course, you need to connect your document, your Markdown document, to the BibTeX file I showed to you. So to this file here, literatureN, and I've prepared this. Then you have to remove the hashtag here so that this bibliography is active. And also you have to remove the hashtag here, which uses another file which I also have in this folder here, sports medicine with CSL extension, and this contains a predefined way how literature references appear in the document. I have to see one thing. It's important that these items here in the first in this top section of a Markdown document are in the correct position. So the bibliography and CSL must be not indented like this one here, but must be positioned in the first position here, and then it should work. Let us generate the document and look at the result. Okay. Okay, here you see that the referencing worked. So here's a literature reference, has been automatically added at the end of the document, and the reference I've written here is correctly numbered as number 1. If you want to have the referencing in a different way, for example, reference like Velten 2009, then you have to use different CSL files. Then you have to look into the internet descriptions of BibTeX databases, and there are lots of CSL files available with different citation styles. Here, of course, it would be better to have a different separate section for the references. This can be easily done by just adding another section here, references. And if I now compare the document, I have the final state for this video. Just a moment. So, okay, now we have a separate section here, references, with a list of references, and if I would invoke more references in my text, then this reference section here would become longer. And the document which we compiled in this video can be, all parts of the document can be accessed very easily using this floating table of contents. And this is also very comfortable that you can switch this table of contents off if you don't need it. But if you need it, you can very simply now go to every position of the document you're interested in. Thank you for your attention.